Model data is basically algorithms. You collect all the data from like the weather balloons that are blamed for everything from UFOs to spies. They take all that data, observation data from like our CocoRoss observers and all the different airports, and you put all of that into these supercomputers, and these supercomputers say, okay, based on fluid dynamics, this is what's going to happen with the weather. So you have like the GFS model that is very popular. We also have the Euro model that is a European model that those countries put in for, and it is a private model. It's not a government model. And rather than a three-dimensional model like the GFS is, it's a four-dimensional model. And in order to run that data in the supercomputer, it costs 10 times as much. And because of our sponsors and our donations, we're able to access that data and then share it with you.
Is that the ECMWF
Yes.
model? Yeah.
Yes.
Yeah. I worked at that supercomputer for a while as a vendor, helping them get in some of their new equipment
Oh,
back in the 90s.
we'll have to talk about that. Good stuff. So, well, if we look at the normal grid for a medium range model, which is like your 10 to 2 week type of model, this was what a grid might look like, with the city of Pagosa Springs here and Pagosa Peak up here. You can see that there's really only one grid in between us and Pagosa Peak. But if we look out there, we know there's all sorts of hills that are being affected. So you could be missing the lowest area of pressure, the hottest spot, the coldest spot. So when you put all that data then into the supercomputer and it runs out the answer, it's not necessarily going to be a good answer. So this is Sean's favorite chart. So in the 0 hour to the first couple of days forecast, we're pretty good. And we can tell you that that's probably still a horse's butt. But as we get out into the 2 week point, or 15 days out in our forecast, it starts to look less and less like a horse. That could be a rabbit, it could be a child. So when we start talking about these seasonal forecasts, I'm not talking about 15 days. I'm talking about coming out over here 2, 3, 4 months out, and that could just be a smudge. So there's a lot of variability when we start talking seasonal forecasts, and that's why we try to look and find as much correlation as possible. So the CPC outlook, CPC is NOAA's branch of doing long-range forecasts, shows us in a big neutral area equal chances of, and again this is probabilities, equal chances of being an average monsoon season. And it's interesting, over the last 3 months they've been decreasing their areas above average precipitation. 3 months ago we were actually in the green area, and now we're more in just a neutral area. And this is for July, August, and September. And then as we look at the private models and the other government models, it's for June, July, and August, because that's all they have available now. So I tried to make it the same time period so that there is some correlation there. So we're down here, the pink circle, and the CFS, which is a North American model, is saying above average monsoon moisture. So it's flying in the face of what the CPC folks were showing. See, below average. Oh, another North American model above average. Think about the horse. So when we look at the Euro, which is that European model again, it is showing for our area probability of less than average monsoon to average monsoon. So much different. And then if we look at the Canadians, the Canadians are saying very much a very moist summer and probability of a very moist, a good monsoon. So we're rooting for the Canadians, eh?
Pushing out the moisture tongue there. That is
Oh,
what
so
you want to
this
see.
This is showing that moisture coming from the Gulf area up and through Mexico and then swinging around that ridge, you know, and right up into our area. So that's awesome. I like to see all the models showing it.
Go back.
Okay.
Well, yeah. So here, it just hints at it just a little bit. You know, it's got this little band right here of mostly above average, and it kind of peters out over us. Wow. Good. And in here, it's almost the opposite. There's almost no monsoon moisture in here. So these are all, just like Arlene says with the...
So going back to the air masses again, you know, down in Mexico and Arizona and New Mexico, you have that very dry, very warm air mass. And so that's what this is reflecting, is that things are very warm and dry down there.
Yay.
With the Canadians, though, they're reflecting what we want to see.
Do you have any historical data on